Hi, welcome back. We're doing our review for the Chem 4 final. We're learning how to write an equation for a neutralization reaction. Remember, a neutralization reaction is an acid plus a base. Our products are going to be salt and water. Now this is acid plus base reactions. Neutralization reactions are double replacement reactions. Here are the steps to create the products for a neutralization reaction. Number one, switch the second part of the formulas. Switch the anions. So H is going to gain OH, and A is going to gain SO4. Only SO4, only polyatomic ions keep their subscripts. So only the 4 is going to transfer. This little 2, since this is only H, that doesn't carry over. So let's give H a new partner, OH, and let's give Na a new partner, SO4. Next step, we need to look at the products and determine the oxidation numbers. If they don't add up to equal 0, we have to crisscross them down so they become subscripts. Now, what is the oxidation number of sodium? Sodium is a 1A, group 1A compound. Here's our oxidation number line from Chem 3. So sodium has an oxidation number of +1. Now, what is the oxidation number of sulfate? Well, I don't have time to teach you Nick the Camel because that would solve this right away. But what we can do is look back at the compound it came from. You know, hydrogen is a 1A, so that has a +1 charge. And we have 2 of them. So in this compound, we have a 2+ charge on the hydrogen. So in order to equal 0, we deduce that sulfate has a charge, an oxidation number of 2-. Now, do these two numbers in our product add up to equal 0? They don't. Since the oxidation numbers in the products do not add to equal 0, we have to crisscross the oxidation numbers. So what does that mean? It means I'm going to bring this +1 charge here down as 1, and I'm going to bring this 2 charge here down as 2. So our equation becomes H2SO4, sulfuric acid, plus sodium hydroxide yields sodium sulfate plus water. Check. Now, the last step we're going to do is use the coefficients. We're going to add numbers in front of the compound to make sure we have the same number of each atom on both sides of the equation. 1, 2, 3 hydrogens. Since hydrogen is in 2 different compounds, let's start with something else. 2 sodium, 2 sodium. Now we have 2 hydrogen plus 2 hydrogen is 4 hydrogen, so we need a 2 here. I know I'm going fast, I'm sorry. This is now a balanced equation. Just trust me on that. So we did step 3, use the coefficients to balance the number of atoms on both sides. That's basically it for how to write a neutralization equation. So for any neutralization equation, for any ice chart, at the top, you always need a balanced equation. And our balanced equation, when you have an acid plus a base, is a double replacement reaction. And double replacement reactions, in order to write the products and balance the equation, you're going to use these 3 steps. One other thing with neutralization reactions, remember you have to be nice to the moles. So when you're doing a neutralization equilibrium chart, we need moles. you can use molarity times given volume to get number of moles. You're going to multiply them. Now, your ice chart is going to use moles, and then after the nice, and this is where people make the mistake, after the nice chart, you have to change back to molarity. And the way we do that is with this equation, molarity equals number of moles, which we have at the end of equilibrium chart, but you have to add the volume of the acid and the base, because that's the total volume of the solution. So now we're all ready to try an example of finding the pH of a neutralization equation. Bye-bye.